this is going to be in line with the theme of the event, which is APIs. A lot of the APIs that we use today do use JWTs. We'll try to understand what are JWTs, how do they fit into the entire picture, and also get some clarity on how they are useful to ensure we have a secure communication mechanism across the entire ecosystem. Before we start, hello, I am Abel Mathew. I am a software developer. I have been professionally writing code for almost 2+ years at the moment. I am passionate about open source and community, and I've always been interested in participating in multiple events that involve open source or community driven activities. I am an Auth ambassador. A lot of the references that I use today regarding the security aspects are referenced from my learnings as part of an Auth ambassador. Alongside that, I have been part of other communities like Google Cloud Champion Innovators and editors for a few of technical editorials is what I would mention. So let's get started. So before we start off, the primary question that always comes for us, and one thing I wanted to say is that if you folks have any questions at any point in time, feel free to put it in the chat. I can see the chats alongside the video as well, so you can do that. So continuing from where we left off. So why do we need cookie or tokens? So let's assume that you build your own application, a fantastic application, let's say to order food. And let's assume people are signing into the application using, let's say, Google sign-in, because you do not want users to have an experience of creating user accounts, creating a password, remembering the password, and all those aspects. So hence, to ease the control for you as a developer and for the end users, let's assume you have enabled Google sign-in. So what happens now is that you as application developer want to know who the user is and to know if the user is a valid user without the user giving you his or her own Google account password. So that is the use case that we're trying to look at here, wherein people are trying to use secondary or social accounts to log into your websites, and you want to confirm their identity without sharing passwords. And that's where the concept of cookies or tokens are primarily used. You do not want to share password to validate the user. So how do you validate the user without sharing critical information is the primary goal here. The other advantage of using a cookie or a token is the fact that if you don't have a cookie or a token, every time you visit a new page, like let's say google.com, from there you went to let's say Google search page, you do not want people to enter password every now and then, because if a user has logged in once, you want to ensure the user is able to navigate the entire application without having to use additional passwords, additional login mechanisms over and over again, because that once again is bad user experience. So that is the problem statement which led to the beginning of usage of cookies or usage of tokens. Just a second. Yeah. So that's all to start off with. Why do we need cookies or why do we need tokens? So moving forward, there are two terms that you primarily hear in this world, in this space. The first is OAuth, and the second is OIDC. They are used interchangeably at many places. I want to explain how the two are different and how the two are interrelated. So both of these are open standards. So these are standards which are used across the globe by multiple applications so that there is a consistency in information exchange. The first is OAuth, which stands for Open Authorization. And the second is OID, which is OpenID Connect. OpenID Connect primarily answers the question, which is, who are you? So it gives you information like what's the profile picture of the user, what's the username of the user, what's the email address of the user. Anything which is involved to your profile information is what OIDC is. The second is OAuth, which is, do you have access? Just because we know who you are doesn't mean that you have access to all the resources. So this is primarily where you have the concept of 401 unauthorized error in HTTP, and 403 meaning access denied error or forbidden error. So in the first case, we do not know who the person is, which is 401 is what we typically call, which is unauthorized. The second is 403, which is forbidden, or which essentially means that we know who you are, but you do not have access to this particular resource. So this is along the lines of you are at a restaurant, we know who you are, but you are not allowed to go to the kitchen because you came here as a guest, not as a chef. So yes, so that's primarily the difference between OAuth and OIDC. Moving forward with what we have. So the other part that I want to explain is sessions. So a session essentially is what do you call? The easy way to explain would be, so you as a user are browsing, let's say, a website. We want to, so let's say you are on a website, you are browsing it. From there, you went on to a separate page in the same website. So let's say you have a food ordering app. You are initially on the list page. From the list page, you went to the restaurant's information page. Now we want the user information to be shared across these two pages without having to log in again and again. So a session is maintained by the browser, which ensures that your information is shared across pages, shared across navigations that you do, across multiple pages that you do. There are primarily two ways to manage sessions. The first is known as server-side sessions. The second is known as client-side sessions. I'll explain both of them in brief. What happens in server-side sessions? The first thing I'm explaining is server-side sessions. The first time you log in or open a website, the server sends some information. It assigns you some session ID. It could be session ID 1 or any of those. It gives you some identification which the server can understand. So the server can choose whatever mechanism the server wants to. So every time, next time onwards, whenever you request pages from the same website, you send the ID that the server had initially sent you. It's like an ID card that you get from the server. What happens in that is that all you have is some number which the server only can understand. That's server-side session. The second is client-side session, wherein we have an ID card at the client side itself. The ID card has the information regarding who the user is. The first case, what you have is a session ID. Only the server knows which user is mapped to which session ID. There is no information about the user in the session ID. The second case, in client-side session, the user information is part of the identity card that you are looking forward to get. So that is the two primary difference. So in server-side session, the first concern that comes is that for a large-scale application, you mostly have got multiple servers. What happens is that for a website, let's say like mlh.io, it's possible there are multiple servers that serve the same content. So the first time you request a website, let's assume it went to server 1, and server 1 gave you the ID of 1. This ID 1 can be understood only by server 1 and not by, let's say, we have a separate server 2, then server 2 cannot understand this particular ID. This leads to the problem wherein only the first server who gave the request is able to understand the session ID, or else you need to have a mechanism wherein you are able to share this ID by storing it at a storage mechanism. So that is the concern with server-side sessions. The advantage with client-side session is that the ID card itself has got the user ID. It does not have a concept of separate session ID. When I'm mentioning ID card, I'm giving an example outside the world of tech. When we actually implement it, it is usually a JWT token, which we will cover sessions next part. So that's the primary difference between a server-side session and a client-side session. As you can see, the advantage of client-side session is that you are able to scale very easily. You do not have to do an additional search to know who the user is, because the user information is directly there in the JWT token. There's one scenario in which server-side session is useful, and critical applications like banking applications, financial applications use server-side sessions. The advantage is that because the server has tighter control over the session, it is very easy to log out a user. So let's say someone stole your session information and someone reported it. It's very easy for the server to just say that session ID 1 is now invalid. Whereas for client side sessions, it's difficult to manage that. That is the concern with the client side session, where security aspect is possible. It is a little bit more difficult to reach the same level of security. I hope I am clear and we can move forward. So moving forward to the next aspect, which is JWT tokens. Some of you may have heard this. So JWT stands for JSON Web Tokens, which is pronounced as JWTs. You folks call it JWT tokens. You can call it JWT tokens, whichever way you feel like. The convention, or I would say the recommendation, is to call it a JWT token. Does not mean that other pronunciations are wrong. This is an open standard that defines a compact way for transmitting information in the format of JavaScript object notation, which is a JSON object. So what you see below is an example of a JSON web token. The first site, if you take a look at it, what happens is one may wonder that it looks like a string of characters, and I do not see it to resemble anything like a JSON, because a JSON usually has an opening curly braces, then key value pairs and double quotes is what the usual convention is. So how is the string that you see below an example of a JWT token is the question that usually comes. So this is a JSON web token. It is not a normal JSON. What we have done is something known as encoding. Encoding is a way for translating stuffs if you have to look forward to a non-text explanation. So if I quickly screen share my browser, so let's assume we are at, let's say, google.com. We are here. So if you can see, if I, okay, so cannot see my screen. Yes, you can see my screen, yes. If I type a space here and then an MLH, so what I wrote is space and MLH, but if I press enter, that's not a good example. Let's assume we go to mls.io. Yeah. So if you remember, what I wrote was q equal to a space b, which is a space b. The moment I press enter, you can zoom in a little bit if you want. The room is not so useful. The moment I pressed enter, it converted space to percentage 20. So what happened here is something known as encoding. So we do something very similar for JSON Web Tokens, wherein the string that you see over here, so if I copy it here, it is something known as base 64 URL encode. So there is nothing fancy happening. So if I go to any base 64 URL decoder, so I am at this particular website, I paste this information and you can see that this was decoded into a JSON which has the key as ALG, which stands for algorithm, and it has type as JWT. So this piece of string is essentially this same piece of string in a different format. So if we have to do the other way around, well, if I want to run encode, I can do something like, let's say, I can do a colon b and plus encode. Oh wait, wrong thing to do. I almost all this was little concerns. So plus the encode button. So you say this is the encoded value for this JSON that we had initially passed. So that's what we are trying to do here. So the format of the JSON Web Token is a.b.c. The first part is called as the header. The second part is called as the body, and the third part is the signature. The signature is the interesting aspect of the JSON Web Token. I will quickly explain that. Just give me 10 seconds. I'll be back. I have just one thing to take a look at. And I'm back. The answer to your question, Gerard, is it is always base 64 URL encoded. It is not just, so it is actually base 64 URL encoded. And yes, that is part of the standard of creating a dot token, that you have to follow this particular standard. The main advantage of doing that is because the curly braces, the special character, the spaces, the enters, all of that get compressed into a standard convention, which can be a normal plain string, which you can send across at multiple places. So that's the main advantage that we're looking forward to by using something known as encoding. So moving forward, the interesting part of a JWT comes from the signature. So as you can see, if you have got this particular JWT token, I take this token. The website I'm using for decoding is JWT.io, but there are multiple libraries. You can write your own small piece of code to do the entire thing. This particular website also does the same thing underneath the hood. It's just a beautiful UI to play around. That's the advantage. So as you can see, the third part is something known as a signature. What happens in the signature is that you take the first part, the second part, and then you have a key, you hash it, and then you encrypt it. This ensures that the signature can be verified or can be tampered with only by the person who has the key. So what usually happens is that you, as the application owner, would create the JWT token for the user and give it to the user. So let's say this JWT token gets stolen. So if, let's say, the subject is written as welcome to MLS Nights, and let's start from the very basics. I don't have anything here. And I refresh the page. So what we will get is a sample JWT. And let's assume that this is used to access some critical information. Sub is a standard. So these are all standards that ALG stands for algorithm types, TYP stands for type, sub stands for subject, which usually is user's ID, user's name, and those formats. Issue that usually means IAT stands for issue that. Some JWT tokens also have a concept of EXP, wherein EXP stands for expiry. You can also set an expiry. So you can set multiple parameters that you want. The interesting part is the signature. So I, as an owner, let's say I put a signature, signature 1. So this is the signature. So assuming that I do not have this signature, because this, the person who created it would have, no one else would have it. It is impossible to recreate this, which means if I don't have the signature and I put an information here, or you try to tamper with it, it is not possible to tamper with it. Let's say you change the expiry from 222 to 322. Without the signature, this third part would be very different, and your server can know if someone has tried to spoof it. So a JWT, signed JWT, is tamper proof, but the information can still be seen because it would say signature is unverified, but still the information can be seen. So a JWT is not a mechanism to hide information. By default, there are ways to hide information if you want to, not in the example that we're talking about. It's a way to ensure the information is cryptographically signed and tamper proof. So I think that explains the basics of JWT, how signatures work, and how it ensures that if someone tried to tamper it, play with it, steal it, and try to modify information, let's say someone stole an expired JWT token, and if someone tries to, let's say, change the expiry date, but if they don't have the secret, then the validation would change. So that's where the whole picture is. I suppose that explains what JWT token is and what the basics are. Moving forward. The next part I want to talk about is something known as authorization tools, this is where the interesting part comes. This I want to explain because let's say you're on a website, let's assume like GitLab. GitLab has Google sign-in. you go to GitLab and then you click on Google sign in. So first you run gitlab.com, then you go to Google, and then you come back to GitLab, and then you're logged in. So I want to explain how the entire application flow works. This is the example screenshot from Auth0 that I've taken. This can be different. So this part of Auth0 tenant here would be the website which the user is logging into. So in terms of, let's say, Google sign in, this would be a google.com website. So that's the whole picture. So the first step is that user logs in. So the regular web app is your application, anything that you have created. And this part over here would be your authorization server. The user goes to the login link and an authorization code is sent to the 10 to the authorization server. And now, as you can see, the response 3 comes back to the user, and then the user logs in. So the step 3 and 4 bypasses your website. So this ensures that the username password which you enter, let's say website like google.com, is not shared with your website. The user is directly logging in to his or her own authorization server's username password. Once that is finished, an authorization code is returned back to your application. So all you get is an authorization code, not the username password the user initially entered. And then you use this authorization code along with a client and client secret, which I will explain, to get back an access token. The ID token in this scenario is the token you get from OIDC, which is telling you who the user is. And the access token is the Auth access token, which gives you access to specific APIs that you want to call. The concept of client ID and client secret is to ensure that only verified applications are able to get user access token, wherein you do not want some random website to come and get Google access tokens saying that I am a rightful website owner. So a client and client secret verifies the website. So in this example, if I'm taking, let's say, GitLab, so the client and client secret tells Google that the request is coming from a valid website known as gitlab.com. So that's the whole picture of using a client and a client secret. This is one of the many examples of an authorization flow. There are multiple other authorization flows in the Auth standard. You can check that out at Auth0's website or any of the websites. You can directly do a Google search. It's very interesting to read how these are used to ensure behind the scenes mechanisms that happen when you click a login button, then you enter password, and then you come back to the website, and the entire thing works flawlessly. So this is the underlying mechanism that actually happens. The second part I want to explain before we conclude the basics of how JWT tokens secure the internet is something as refresh tokens. This again is also a screenshot from the Auth0 website. So this AS in this example, you assume it to be your authorization server, which could be google.com or any website which is handling user access control or user session. The SPA is your website, single page application, the applications or any of application which is an SPA. And RS is your API or protected resource. So someone may not steal your password because you have implemented this Auth mechanism, but someone can still steal your access token. So the question that comes is that what happens when someone steals your access token? Because you want to ensure that if someone steals your access token, then the possibility of them misusing it is very small. So what has been done is that in the new mechanism, this auth flow has got an include auth flow, which is something known as authorization code flow with PXE, which stands for PKCE. So that flow ensures that you get an access token with very small expiry time. So let's say you logged in now, but your expiry time is 5 minutes. And along with that, you also get something known as a refresh. Refresh tokens are used to get new access tokens. So your application now has got two things, the user's access token and the user's refresh token. You use the access token till the expiry of 5 minutes or whatever the short time is. And then you use the refresh token to get a new access token, and then you start using the new access token. This ensures that you can have long sessions without having the user to log in over and over again, because you can refresh the tokens using the refresh token. So the fair question once again comes is, what if someone steals the refresh token? Because if someone can steal the access token, they can very well steal the refresh token. The interesting aspect is that refresh tokens are monitored, which means that if you have got refresh token 1, so you are using refresh token 1, and let's say the attacker stole it and the attacker is also using refresh token 1 now. The authorization server, the example A that you see on the screen, will track refresh tokens, which means, so you as a user do not know your token was stolen. So you go to the server to refresh it with RT1. And then the attacker also goes to the server to refresh with RT1. So what happens is that the server now sees that RT1 was reused. So refresh token reuse is scanned. The moment a refresh token reuse is identified, all refresh tokens are revoked, and you do not get a new access token anymore. So the advantage of using a short-lived access token with refresh token is that even if someone steals it, they can misuse it only for a maximum of X amount of times, which the expiry is. So if an expiry is, let's say, 1 minute of access token, they can misuse only for 1 minute. So this enhances the security based on how critical your application security is. The expiry time is kept small, and if your application is not mission critical, let's say like a food ordering app, then you keep it along the lines with 5 minutes, 10 minutes, 1 hour, or any of those lines. So that is the basics of how refresh tokens are used, how they are used to get a new access token, and how refresh token reuse scanning mechanism ensures that you get security at the same time. All of this that you see, where refresh token reuse mechanism, refresh token reuse scan, multiple API calls that happen during the local mechanisms, all of this are handled by any of the standard libraries or any of the standard providers you use for creating Auth logins. It could be any website like, let's say, Google login, Auth login from Okta, Auth0, or any website that you use. It is highly recommended that for industry grade applications that you try to use some platforms which have got mechanisms to out of the box enable Auth support, or else creating something which is highly secure, which follows the standard, is time taking. It definitely takes a lot of learning curve to build this and then updates over the time. So yeah, that's pretty much about the basics I wanted to cover. If you have any questions, please reach out to me. If you want the slides, if you want more insights, I'll be more than happy to explain. If you have got questions, feel free to ask.